have the amazing session by the ITRS group, Optimizing Cloud Resources to Achieve Cost Efficiency. For this session, we have two speakers, Zandbergen, Global Head of Strategy, ITRS Group, and Scott Russell, Head of Capacity Planning, ITRS Group. Casey, all yours.
Good evening, and welcome to our session today. What we'd like to walk through briefly is a little bit about cloud spend and how you can optimize your cloud capacity to be able to take advantage of the best that cloud has to offer, while also maintaining operational efficiency and decreasing your spend as much as possible. As we look at companies around the world, we see that about 90% of companies have adopted DevOps as a way to move rapidly. Adopting Agile and DevOps is, of course, a way to quickly develop applications and deploy them to the cloud. And a lot of companies are moving to the cloud simply because they see the flexibility that the cloud offers. But one of the things that we also see is that about 35% of the cloud spend is wasted, which means that you're paying for EC2 instances or Azure instances that you're not utilizing completely, or that you're not utilizing at all in some cases. And that runs up your cloud spend and costs you money. So what do we want to think about? We want to think about how do you first measure what you're actually using. In a traditional data center, you've got 10 in a rack and you have already invested in that server. And so you utilize whatever you can on that server. However, in the cloud, you're actually buying an instance for you to rent and to use. And if you don't use that entire instance, you're essentially wasting money. So the first thing that we want to do is we want to think about how do you right size, i.e., how do you know exactly how much CPU, memory, disk I/O, network that you're using, so that you can then think about exactly what the workload that you need to move from your on-prem data center to the cloud is. In other words, you could just do a like-for-like shift. I've got a certain CPU, a certain amount of memory, a certain amount of disk I/O. I'll move that from my data center to the cloud, which is great unless you're not actually using all that capacity, which means that you're then buying capacity in the cloud and you're not actually using that capacity. So the first step is to right size, measure what you're actually using, and only buy what you need to buy. The next step is to right buy. So make sure that you're buying the appropriate instance in the appropriate spot in the cloud. Once you've identified the CPU, the memory, the disk I/O, et cetera, that you need to be able to run your application, and you identify the location or the region that you want to run in, then you want to make sure that you buy the best plan. Is it better to run in AWS? Is it better to run in Azure? Is it better to run in GCP? You want to be able to compare all the different sizes from the different regions, from the different cloud providers, and make sure that you're getting the best deal that you can for your instance that's going to be running in the cloud. And ideally, you should be doing this on a monthly basis to make sure that you're actually still getting the best deal on a month-to-month basis. So finally, when we think about this, it's really a three-stage process. Right size, measure, and know that you have the right size instance. Right buy, pick the right cloud provider, and pick the right instance size within that cloud to make sure that you're only paying for what you need. And finally, you have to revisit it because applications and needs change. So as you think of moving from one month to the next, you're going to be needing to right size and right buy again on an ongoing basis to make sure that you're optimizing your cloud spend. It's only by doing this that you actually know that you're getting the best buy for your dollar, and that you are actually getting the best bang for your buck from a cloud spend perspective. I'm now going to hand this over to my colleague, Scott Russell, who's the head of capacity planning at ITRS Group. And Scott's going to walk us through a demo of how to right size, right buy, and to optimize your cloud spend. Scott, handing it over to you.
Sure, thanks, Casey. As Casey said, I'm going to take you through a very short demo, just giving you a brief introduction to our product, ITRS Capacity Planner, and I take you through the capabilities on right sizing and right buying for moving into the cloud, and then once you're in the cloud, optimizing your cloud spend by doing this on a continuous basis. ITRS Capacity Planner it isn't a real-time tool. It's a strategic planning tool that takes data from the monitoring tools that you already have across your organization. Tools such as vCenter, SolarWinds, our own tools such as ITRS Genius or OP5 Monitor. That monitoring data gives us real rich insight into the demand profile of each one of the machines which is running in your organization. And we're looking at one of them right here just now. This is one of my virtual machines across my estate, and this is 1 day's worth of time series data that we have. Now we've got this for CPU, memory, I/O, we also have storage data, but for the purpose of this demonstration here, we're just going to look at CPU for the time being. So I can see that daily utilization profile of CPU. And then we summarize that profile using what we call the box plot that gives us a good picture of the variance of this metric over this period of time, being 1 day. Now, if I just click on this, I'm going to move back and take a step back into building up a demand profile of this utilization over a longer period of time. Here we have a similar box plot showing me the variance in utilization for this particular metric, CPU, over for each day. And we can see that we have a number of measures on each day. If I just pick this day here at random, I have my peak CPU for that day. I have my 95th percentile. My 95th percentile means that 95% of the time, CPU demand on this particular machine was at that level or lower. Or to flip that round, 5% of the time, CPU demand was at this level or higher, reaching a peak that we can see here of 59.3%. And that becomes really important when we start looking at right sizing and right buying for moving into the cloud and being in the cloud. Now, we have a long history of data for this particular machine. In fact, all the machines I have in this environment have about 13 months worth of data. And as I scroll back, you'll see that that demand profile changes quite significantly. We have quite a lot of variance on a daily basis, but if we go back in time, then our utilization was much flatter. And if we were right sizing for a cloud or buying for a cloud when this was our profile, we almost certainly would have bought more capacity than we actually need based on this profile now. So that shows the importance of having this understanding of this demand profile. Now, on the left-hand side here, I see a summary of this particular machine over the last 3 months. In the last 3 months, I can see the peak CPU demand and the 95th percentile and another bunch of other stats which we may use. And the platform gives you the capability to choose the stats that you want to use, and we'll see that as we go forward in this short demo. So in this case here, 95% of the time over the last 3 months, this particular machine has been at 59.8% or higher, reaching a peak of 77.5%. Now I can just take a step up into seeing this machine at a higher level. If I just open up the summary of this machine, then you can see the summary that we use here. We can see the configuration of the machine from both a memory, CPU, and a storage perspective. We then build this picture. We call this a sunburst, which is a hierarchical overview of your data center estate. We can see our clusters here. We have two data centers, sorry. Then within each data center, we have a number of clusters or logical collections of machines. The outermost ring are the physical servers that my workloads are running on. And then each one of these circles around the outside are my actual virtual machines. And these are the machines which are wanting to move into the cloud. And we want to make sure that we right size and right buy for those. The color gives me an indication of how close to capacity each one of these components are. And you can see the lots of dark blue machines here. Using this sliding scale, these dark blue machines are machines which are potentially over-provisioned, machines which are bigger than they need to be and perhaps could be right-sized and made smaller. If we see any red machines or particular machines with circles around them, these are machines which are really resource constrained, and perhaps we want to make them larger and give more capacity to them in order to increase their performance. Once we understand this profile, this baseline as we call it, and this baseline is based on a rolling window over a 3-month period, we can then start to make recommendations across the machines that we have. So looking at the activity of these machines, we have a large number of machines which are idle and could be potentially switched off. We also have a number of machines which are under-provisioned, these machines which could potentially be made larger. And then we have a significant number of machines here, 776 machines across my estate, which are over-provisioned and should be right-sized, machines which should be made smaller. Now we come to the cloud migration. We want to look at right-sizing and right buying. If I took this entire estate here and just moved it into the cloud on a like-for-like basis, then you can see that the options here for AWS and Azure, how much that would cost me to run a significant amount of money, $210 an hour to run this environment like-for-like in AWS. And for like, as Casey was saying, that means taking the configuration as it is and then moving that to the cloud without making any changes based on what they actually need. We can also see there are significant savings to be had by right-sizing. That's if I take those recommendations, and that doesn't mean switching those idle machines off. That simply means taking those idle machines and making them as small as they need to be. If we right-size those machines, we can see across both AWS and Azure, we have significant savings that can be made. And if I just look into those kind of savings in a bit more detail, here's all my machines. Here's the recommended instance type. These can all be exported from the product, or they can be pulled out via an API. And if I look at the recommendation chart in a bit more detail, this is the current configuration of the machine. If you imagine each one of the axes that we see here from left to right is a measure that we are using in our calculations in determining the right configuration for the instance size in this case. And looking along the bottom, I can see I've got a 2-core 4 GB virtual machine here. Now, based on the box plot and demand profile here, it's a very low use of CPU and also similarly low use of memory as well, but slightly more variance in that memory metric. Then based on some levers that we can pull, I can see the recommended machine here is the T2 Nano. Now, that's a burstable machine. I can see from the CPU utilization that burstable machine has significant enough capacity to support that CPU profile and also has enough memory capacity as well. And I can see how much that's going to cost to run per hour, 0.0086. So potentially significant savings as we move through various recommendations, through various configurations that you can use for this particular machine. Now we can tailor this on an application basis. If we have enough mapping information that allows me to identify a particular application, if I just bring in some of that information here, I'm going to pick one particular application. I've got one here called BCMS. You'll then see that our migration options for moving to the cloud, like for like or right-sized, have changed. They're now tailored based on this particular view I'm looking at. These are applications, workloads. This is an application called BCMS, and each one of these circles here represents a machine associated with that application. That data could have come from CMDBs such as ServiceNow, for example. And I can tailor this recommendation as well. So I could go to my AWS Migration Rules, and I can say, well, okay, I know that this particular application needs to be, for example, memory optimized. Perhaps it needs to run in one of a number of different regions, and I can choose options for my regions. And I can also pick network performance and storage class as well if I have insight into that kind of performance that I require. I can do that, and it will dynamically update my recommendations to give me a price for moving to the cloud based on that particular configuration. And you can see that there. Even though I picked a very particular type of instance running in Oregon and US West, I can still see there are significant savings to be had as a result of right-sizing. So that's moving to the cloud. Now let's move into the cloud. Now, this visualization here is a heat map of instance activity. We're looking at a cloud environment here that has almost 10,000 instances, and I've ordered those by levels of activity. I have the machines which have high levels of activity, and I have idle machines, low machines, and machines which have normal levels of activity. And we're using the exact same type of analysis that we saw on the time series there. Where I see blue is where I have very low levels of activity. This is where instances are running cold. These are opportunities to save money. Perhaps using this heat map, I can identify periods of time over the weekend when I could switch machines off, or period of times overnight when I could switch machines off as well and automate that. I also have a significant number of machines which are doing nothing from a resource perspective, and there's savings to be had by potentially switching those machines off as well. Along the top, I see two axes on this chart. The grey, the black line here is the number of instances running at that point in time, and the blue line is the costs of those instances. So I can very quickly identify my busiest days and my most expensive days. And down the right-hand side, I have a similar chart which identifies the most expensive instances or groups of instances that have been running as well. Using all that analysis, we can then make recommendations similar to what we had in the on-premise moving to the cloud, but recommendations on savings that can be made on these particular machines. So we have 192 instances here which are currently running, which could be potentially switched off. And by doing that, I could save significant amounts of money per month here, so almost $50,000 a month by switching these machines off. I have a significant amount of machines which are over-provisioned and should be right-sized, again, potentially saving significant amounts of money. And if I look at the detail of that, similarly to what we have in the previous example, moving to the cloud, we can also see the recommendations that we have here as well. And if we bring that up, we can see the CPU core utilization, the current configuration of this machine, which is the M5D 4X large. Based on its CPU utilization, we could go with a significantly cheaper R5A 2X large. And you can see the savings in there. The height on the right-hand side, how high it is on near to the top, is how relative its relative costs. I can see this is $1.64 US an hour, and I could half the price of that by moving to a smaller machine running in the same environment. We also look at machines which have been terminated. There's machines which may, as Casey said, you have DevOps environments, you have machines which have been automated, auto-scaling groups or scale sets in Azure, and those machines are based on a template or a configuration, and you want to know if that configuration is right. Some tools may attempt to make a change to the instance as it's running, but then when that new machine or new instance of that type and that set is fired up, it will then revert to its initial size and initial configuration. So perhaps we want to look at machines which have been terminated and if there were alternative and cheaper ways to run that. And here we can see that of the machines which have all been terminated, there were significant savings to be had still. We had lots of machines, 446 machines, which were M5X large, which could have been R5A large, and that would have saved me almost $1,369 as a result of that. Again, we actually had a very small amount of machines, which were C5D2X large. They could have also been the R5AX large, and that would have saved me about $1,244. So if we know from these machines the applications that they're associated with, and we can have metadata that allows us to do that, then we can recommend go back to the configuration of that and ensure that when those machines are started again, that they're given the correct allocation of resources. Very briefly, again, just before, we also do analysis on savings plans where we can show the benefit of investing in savings plans, the optimal savings plans, and the average savings that you would make as a result of that. We can also take in the data of your initial and current investment in reserved instances and in AWS for savings plans, and combine that together to give an optimal configuration of RIs and savings plans based on your current utilization and optimized and right-sized utilization. So that brings me to the end of my very quick demo. I'll stop sharing now and hand back to the presenter, and thanks very much for your time.